Hi again. In this lesson we're going to look at the topic of different types of computer systems, and in particular we're going to look at the difference between what we might call a general purpose computer system and what we might call an embedded computer system. So this is lesson 3. Specification clearly says what we have to do as part of this particular topic area. Be able to describe what we mean by an embedded computer system and give examples of what we mean by an embedded computer system. So, let's look at a couple of examples looking at these pictures here. What I've done here is put together a couple of examples of what we might consider to be computer systems, but they're not necessarily the type of things that we picture in our minds when we first think, what is a computer system? Typically, we'll picture that device that sits on our desk, monitor, keyboard, mouse, or maybe even the laptop that we carry around with us. But all of these on the board here are also examples of computer systems. So we've got the normal desktop computer system, we've got our tablet computer system, our iPads, our Android tablets, but we've also got things like our smartwatches that keep track of where we are, how many steps we're taking, in some cases even the rate of our heartbeat. We've also got things like ATMs, cash machines, they're a computer system, as well as thermostats, heating systems that we have in our homes, what we might call smart devices. All of these have computer systems inside of them, even though from the outside it might not look like it. So, let's define first of all what we mean by a general purpose computer system. General purpose simply means that we can use it for a range of different tasks. So a general purpose system would be something like a desktop computer or a laptop. Even a tablet computer is general purpose. All of these things have the same thing in common. You can use them to complete a range of different tasks. You just load a different application, load a different program. Goes from a word processor into a spreadsheet, into a games machine, just by changing the program that you're running in memory. And if you remember from one of our previous lessons, this concept that you can change the program in memory and that memory stores the program and the data is called the stored program concept. So a general purpose computer is one that you can use for a range of different tasks. That contrasts with what we call a dedicated computer system. Now if you think about the word dedicated, dedicated literally means it can do one thing in this case. So a dedicated computer is a computer that has one specific function. It can only do one thing. So a typical example of a dedicated computer might be a calculator. The calculator can only be a calculator. It can't do anything else. You can't load a different application or a different program. This device is hardwired from the point at which it was made to simply be a calculator. So a dedicated computer system simply is a device that has one specific function. That's linked in to this idea of an embedded computer system. If we've got something that is embedded, it means that the computer system is hidden in another device. So here we're looking at something that does not look like a computer system. You typically can't see the conventional keyboard, monitor, mouse. So something like a fighter jet would be an embedded computer system. Something like a car has lots of systems hidden within that car. You've got the ABS braking system. You've got the engine management system, the air conditioning system. You've got the alarm system, the entertainment system, the GPS, the satellite navigation system. All these are computer systems that are hidden within inside that car. They're embedded. So an embedded computer system is one where the computer is hidden in another device. Now, just to give you an example, I'm going to show you a short video clip of what can happen if we become too over-reliant on embedded systems, on computers. And this is something that we have to consider when designing systems that rely on computers. We're not always as good at getting computers to do what we want them to do than perhaps we might.
Aircraft manufacturers have tried to fix that problem by designing the pilot out of the cockpit. This is the first fully automated plane flown by a computer.
So, just as an example there, we've seen what can happen if the computer system goes wrong when it's embedded inside another device. Obviously that's an extreme example. Most embedded systems are thoroughly tested, are reliable, and most of them are relatively simple. They're doing things like controlling the central heating in your house, or controlling the box below your TV that's your personal video recorder, your Sky box or your TalkTalk box. Okay? Nothing serious is going to happen if that system fails. It might not record the program, it might end too soon, the program might end part way through and the box crash, but nothing serious is going to happen. But occasionally we put computers, just like in that video clip, into systems where if things go wrong, there could be serious consequences to either life or property. Let's have a look at another example of where we might be putting computer systems into roles that would normally be carried out by a human being. So I've got another video clip queued up, ready for you to watch.
What's on? When you know which film you want, just say its name. The Adventures of Tintin.
The Adventures of Tintin.
Certificate PG. Tinker Tailor Soldier Spy.
The Adventures of Tintin.
Johnny English. Reborn. Certificate PG.
I thought he said just say...
Midnight in Paris. Certificate 12A.
The Adventures of
The
Tintin.
Three Musketeers. Certificate 12A. We need to talk about Kevin.
No, we don't.
50. Please repeat.
The Adventures of Tintin.
I didn't catch that.
Looks like the Adventures of Tintin will have to wait.
Okay, so that video clip was another example of where a computer system is being used to replace a human being, but it hasn't quite mastered the skill that the human being would have in that situation. It's demonstrating what we call voice recognition or speech recognition. Now, one of the things that we need to consider as we start to develop computer systems that can take over human roles, that can be embedded in more and more devices, is reliability. We've seen that in the sense of the plane crashing. In that scenario, what appeared to be happening is the pilot was doing a low flyby to show off the capabilities of the plane, and the onboard computer system thought that the plane was landing. When the pilot decided he wanted to pull up, the plane overrode the decision of the pilot and tried to land the plane. Unfortunately, the plane ran out of runway. That was a situation where the programmer, the person writing the software, thought that they knew better than the pilot on board the plane. We might see similar examples with modern day cars, where we have collision avoidance systems, where the car overrides the input from the driver to accelerate and applies the brake to avoid the impact. But could we think of a scenario where the driver might need to accelerate, to avoid a situation, and the computer system on board the car override that driver's decision, which could lead to a serious accident. Just something that we need to consider. So reliability, robustness, how robust, how solid is the system? Can it stand up to the day-to-day rigors that it's being put through? Is it safe? You know, just because we can replace a human being with a computer, does it mean that that computer system has the same instincts, has the same level of intelligence, the ability to deal with novel situations that the computer might not have? Computers are very good at doing boring, repetitive tasks over and over again that have a well-defined set of parameters or instructions. But if something is slightly ambiguous, if there's not a clear do this, do that, do the other process, computers tend not to be so good at them. And then of course, what are the legal issues, the ethical issues? What about military now replacing fighter pilots in planes with remote controlled fighter planes that are controlled from a distance, that don't put lives at risk of the pilots? Does that mean that wars are more likely? Because we can conduct a war with fewer casualties, because we're not putting pilots into planes or drivers into tanks? How long before we have fully autonomous planes that don't even need a human operator? So there are some of the issues that we need to think about in terms of, is it wise to replace human beings with computers? And what about jobs? How many people potentially might lose a job because it's now being replaced with some sort of computer system? Think about the self-checkout systems in the supermarkets. If you're using a self-checkout system, potentially there could have been a human being operating that checkout, getting paid, earning money. Or are computer systems just stopping human beings doing those boring, repetitive tasks and actually allowing human beings to do more interesting things, more highly skilled jobs and roles? So it's positives, but also negatives. So let's have a look at some of the key terms that you need to make sure you've got well defined. You need to define what we mean by a general purpose computer. A computer that can be used for a range of different tasks. Just load a different program and the computer can be used for something different. You need to know what we mean by a dedicated computer system. A computer that is designed to perform one specific function, one task only. And then what we mean by an embedded computer system. A system that's hidden in another device. Could be a heating system in a house, it could be your video recorder under your TV, it could be the systems that make up your car. And then finally, it's always worth thinking about the consequences that including computer systems in lots of different roles can actually have. The jobs that perhaps it might mean no longer exist in the future. Just like in the Industrial Revolution in the 17 and 1800s, lots of jobs that were manual disappeared, were replaced by mechanisms, machines. So too in the 21st century are we seeing more and more jobs go because they're being automated. And not just by robots. It could be automation by software robots, programs that run on a computer system that would do a task that a human being would normally do. And one of the important things about school, and this is something that students often question, why am I doing this subject? Why have I got to do this thing in English, or this thing in maths, or this thing in DT? It's about developing learning skills. Developing those skills to learn something new. Because one of the things that you guys will have to do, perhaps more so than me, is switch jobs during your lifetime. It's very unlikely that you are going to stay in the same job. That job may be automated, that you may need to learn new skills. And the skills that you learned in school about how you learn about how you engage with something that perhaps doesn't always interest you, but you have the discipline to engage with something that doesn't necessarily interest you and learn it, might mean that you end up being the person better prepared to take on that new job. 65% of today's 12-year-olds will end up doing jobs that don't yet exist. We don't know what those jobs are. You don't know what those jobs are. But you need the skills to learn, to develop and improve. If you're interested in this, if you search for the BBC's Will a Robot Take Your Job, you'll find a page where you can actually type in the job that you might be looking for, and it will tell you how likely it is that that job will be replaced by a computer, will be automated in some way. I searched for secondary school teacher. The good news is that there's a 1% chance that my job will be replaced by a computer in the short term. So hopefully I'll still be here in years to come teaching. Hope you've enjoyed this lesson. As usual, there's a link to the presentation below the video. Thank you for listening.